Hey everyone. I know that I'm the last presenter before your lunch, so I'll be brief. But this, I think, is one of the most important technological advances in the last 10 years, and it intersects very closely with cryptocurrency. So I think you'll find it to be interesting. A bit about my background: I'm a former investment banker, tech investment banker, capital markets. I also manage a $20 million crypto hedge fund called Decentralized. So I'm very familiar with kind of token economics. You can find me and follow me at STORJQ on Twitter. So many of you probably know the amount of data in the world is exploding. Currently, we're at about 44 zettabytes, growing to 175 zettabytes by 2025, according to IDC. Basically, this is being grown by content from you, user-generated content. So videos of you and your friends and family, selfies, as well as AR, VR, 4K video, things like that. Internet of Things is also a big contributor of that. So massive, basically data is doubling every 2 years. The way that data is being stored is also changing. So you look at the public cloud and the private cloud, they're gaining share against traditional data centers. So, again, in the market, the pink section is about worth $80 billion today. As that increases market share to 2022, that's actually going to be closer to $200 billion. So that's the market that AWS, Google Cloud, Microsoft Azure, and Ali Cloud participate. And currently, Amazon's printing about $10 billion per quarter. So it's a huge market, it's a growing market, and that's really the last trend over the last 10, 15 years since Amazon came and basically introduced the public cloud. That's the way things have been moving. But there's a problem. The cost of this is we live in a surveillance state. So these are actual presentations that Edward Snowden disclosed regarding the NSA and how they've co-opted the big cloud players as honeypots of information that are used to spy on citizens. And it's also not only government that's doing this. Very often there's hacks of basically these honeypots of data where all this data is in one place, and then hackers come in and are able to steal your information, causing great turmoil to people as well as to companies. So part of what we're seeking to do is basically claw back some privacy and security from what has been taken from us via the public cloud. So if everything is moving to the cloud, maybe we need a new kind of cloud, one that's private by design and secure by default. And that's the mission of storage. So how it works, it's pretty simple. So, well, it's actually quite complicated, but this slide is simple. There's basically a customer application that's basically loading data. So we're a developer tool through an API. Then basically signals are sent to our satellites where we basically say, okay, this is where the data is going to sit on our network via metadata. And then the data is, and that's done via the uplink. And then the actual data is sent from the customer directly to the storage node operators, and storage is never a counterparty to the data. So we cannot, if we're hacked, it doesn't matter because we don't hold the encryption keys. The same way that, Bitcoin, the concept is if you have your keys, then you have your coins. With us, it's you have your keys, you have your data. And we have no ability to access your data. And quite frankly, we have no idea of what is actually being stored on our data, and we want to keep it exactly that way in case we get subpoenaed. We can't provide anything other than that these users are uploading that data, but we cannot even decipher the data because it's been encrypted into gobbledygook. So how does it work? What happens to the files? The files are encrypted client-side. So if you're loading data onto the network, you're basically you've destroyed it through encryption, and then it's split into 80 chunks. And those 80 chunks are then distributed directly to 80 nodes without touching storage. So then, the idea is that if it's been destroyed and distributed, it becomes super hard to hack into it because on the single file, you have to get the encryption key to decrypt the file, and then you have to figure out what 80 nodes across the 150,000 nodes globally where these files actually sit. And that's just for one file. You have to repeat the same process for your second file. Much less, if you're storing millions and millions of files like AWS, Amazon, Google, Microsoft. And then how does it work? There's incentivization. Incentivization through the storage token where people are basically providing storage capacity and they're providing bandwidth. And the storage token is compensation for them to do so. So raise your hand if you have ever stored anything using storage as a developer. Okay, couple. How about have you acted as part of the network as a storage node operator? Okay, how many of you have taken the tokens that you've earned as a storage node operator and converted them into WAN using something like Upbit? Okay, good. So yeah, I mean, we've been working here in Korea with Korea partners with Upbit for over 4 years, but basically this is how we collectively can pull back privacy and security, and basically the storage token acts as the incentivization layer for everybody to contribute to the network and basically make the world a more secure and private place. So our goal is to create the world's largest, most secure, resilient, performant, and economical cloud without owning or operating a data center. So it's a really audacious goal. We believe that it's very doable, but and I'm going to walk you through how we're going to do it. So we have some learnings. We basically were able to scale our network to about 150,000 nodes over 180 countries, storing about 150 petabytes, which is a lot of data, in version 2 of our network. We also learned that what not to do, and so we basically had to rewrite most of our code base in order to be able to scale to the exabyte range. And so the exabyte range is 1,000 petabytes. And to just put it into perspective, Amazon, Google, Microsoft are all measured in about 100 exabytes. But these people all around the world have been getting compensated in storage tokens in order to provide access to their storage devices and their bandwidth. And then they are liquidating these on Huobi, on OKX, Binance, and Poloniex, and other exchanges in order to buy more equipment and then basically contribute to the network. So, and this has been kind of our proof of concept. And what we're doing in version 3, you can expect us to add multiple zeros to the back of these numbers. So our goal seems totally crazy, but if you look at it, it's really quite possible, doable because there's so much latent supply out there. If you look at Amazon, Google, Microsoft, and AliCloud, they represent maybe 1% of the total amount of data being stored globally. So if we could take the rest of that, the 43.5 zettabytes of data, and bring that into an incentivized marketplace, all of that data becomes in fact, private by design and secure by default. That means that all of us will basically take back the privacy that's been taken from us by the large cloud providers. And we think that is going to make the world a better place. And it's going to open the world for types of applications such that we don't, every time you load a photo up to Facebook, Mark Zuckerberg earns $1, and he probably doesn't need to buy another island. If we were all able to have our own keys and share our keys within an application for our own shared benefit, maybe we could collect some of that value. So we think this is just going to open up a multitude of new business models that are going to be really impactful around the world. So why are our partners choosing storage? It's really around the paradigm of durability, security, and performance. So we're quite durable. Basically, we've never lost a file. We're at 100%. When Amazon launched, they were 4 nines. They're currently 10 or 11 nines, I believe. So because of the architecture of our network and based on the amount of repair, it's a self-repairing system, we may never lose a file. The security, as I mentioned earlier, is end-to-end encrypted. So we never have basically access to your files, and we never will. And then on the performance, the performance has been fantastic from our engineering team, and I'll take you through a little bit more about that in detail. But basically, if you have a distributed system, it just lends itself through parallelism to be much faster, both on the upload and the download. So here are some of the main metrics in terms of durability, retrievability, upload, download. These things in greens are on par or better than AWS. So what I'm telling you is that there's hundreds of thousands of devices all around the world collectively have better performance than the #1 public cloud provider in the world. And I like to give it up from our engineering team led by JT Olio for delivering this, because a lot of companies have failed and they've delivered on it. So give it up for JT. Thank you. He's been working really hard on it. So we've also been validated by the world's largest open source projects. So these companies, we've already signed contracts with them. These are 12 of the largest open source projects in the world. They handle collectively about 75% of all the payloads around the world. Unfortunately, they collect about 5% of the wallet. The wallet is basically taken by Amazon, Google, Microsoft. So what STORJ does is we enable them to basically build connectors with us. They send us data, and we give them recurring revenue into perpetuity. And this basically creates a financially sustainable system within open source, which we think is really important versus proprietary software. So we are offering them privacy, security, as well as sustainability. And this is going to enable the storage project to massively hyperscale. Our attorney said I couldn't mention the names of the companies that this represents, but I'm going to give you a little teaser about some announcements that will be coming soon. So a top 3 consulting, first of all, we've gotten inbound inquiries from like almost 10 Fortune 100 companies. We've had literally companies come and fill out our form that are basically, so they fill out the form for them to basically contact us, which is just absurd considering the scale of those businesses. But the first one is a top 3 global consulting company that basically operate a satellite to store government data and on-prem security. The second is a mobile device data backup and sharing from a top 3 mobile handset manufacturer. And the third is one of the largest storage device manufacturers that's basically going to be both a supply and a demand partner. So these are massive, massive companies that have reached out to us because what we're doing is quite unique. So there's going to be 5 numbers that change here. There's going to be 1 number that stays the same, and I'll ask you at the end of this slide which number didn't change. So this is where we are today, about 3 satellites, about 1 million files stored, about 447 pieces of those files. There's about a 13,000 developer wait list and 2,500 storage nodes. So roll this forward, 24, 36 months, there's going to be hundreds of satellites. There's going to be billions of files stored. There's going to be trillions of file pieces. And there's going to be millions of developers on the network operating millions of storage nodes. And what did not change? Right, so how many tokens are in Bitcoin? Who knows? Yeah, and that never is going to change. Same with the storage utility token. So basically, there's a native token that's basically creating the incentive layer for our entire network. All these things scale. The number of tokens does not scale. And so if you roll forward the growth of our network going from 1 petabyte to 1 exabyte, which is 1,000 petabytes, you can see that based on some conservative assumptions, we'll be paying about $6 million a month in the storage tokens to our storage node operators. This is in comparison to the $2 million we've paid in storage tokens since the company's inception. So as the network scales, there's going to be a lot more demand for the token as we grow this ecosystem and in a way that is going to bring back privacy and security to our internet. So some of you are probably wondering if this is for real or not. So what I'm going to do is do something called a proof of photo. So I'm going to take a selfie with you guys, and basically you can come to the booth later and you can basically check it out. Did it work or not? And this basically, I'm going to take a picture with all of you here, a little selfie. And from that, you guys can come by our booth and check out if the file actually downloaded. So this file is being encrypted, sharded, sent around 80 different nodes on a global basis, and then only I can have access to it. But you can stop by our booth, and you can become part of Web 3.0, because this is the underpinning of Web 3.0. Because once we have data that's decentralized and secure and private, it really opens up the world for everything else that Web 3.0 is trying to achieve. And with that, visit our booth and join us on our journey to Web 3.0. And thank you very much.
Thank you.